Back today, we're going to talk about something that's really pretty simple. Most of you have seen this before in geometry. We're going to talk about square roots. You have seen square roots before, like the square root of 0. You should know that that is 0. The square root of 75. Maybe you've seen the square root of 75 being some approximate value, but perhaps you've seen it as the square root of 25 times the square root of 3. And that becomes 5 radical 3. You should have learned that in a geometry class. What about this one? Square root of 16 plus 20. Square root of 16 plus 20, that becomes radical 36. So that's just 6. So one thing you need to know about square roots, they're like parentheses. You do what's inside of them first. So if you don't know what a square root is, here's a nice little quick recap. A square root is the opposite of a square. We all know that 2 times 2 is equal to 4. So the square root of 4 would be 2. But here's the thing. Every single positive number has 2 square roots. The principal square root of 4 is 2. But the negative square root of 4 is negative 2. So typically what we write, if we wanted to find what is the square root of 36, we would say plus and minus 6. We would actually ask for them. If I just write the square root of 49, then I'm asking for the principal root of the square root of 49, which would be 7. If I wanted the negative one alone, it'd be what's the negative square root of 49, and that's negative 7. That's a little more technical than what we need to get into in the course, but still wanted to make it known for you guys. The symbol is not called the square root symbol. The symbol is called the radical. Alright? Now, things that you need to know. There are 2 types of ways to classify a square root. Rational numbers, which are numbers that can be written as a fraction or a whole number. So the square root of 4 is an example of a rational number because the square root of 4 is 2. The square root of 49 is 7, so that's a rational number. Irrational numbers are ones that are not very nice. That is, like radical 3. There's no absolute perfect nice answer. Okay? So when you punch radical 3 in your calculator, you get an answer of like 1.7305 blah blah blah. Basically meaning that radical 3 is an irrational number. Pi is also an irrational number. So these numbers, you don't have an exact fraction that fits them perfectly. So how would you classify, oh, I don't know, like radical 8? Would you say radical 8 is a rational or irrational number? Well, if you punch radical 8 in your calculator, you don't get something nice like 1, 2, 3, or 4. You could actually break down radical 8 into the square root of 4 times the square root of 2, and you can see that that's 2 radical 2. What about plus and minus radical 225? Well, that's easy. That is actually a rational number. I believe the square root of 225 is in fact 25. Negative square root of 75. Negative square root of 75 breaks down to the negative square root of 25 times the square root of 3. So that would be negative 5 radical 3. Again, you should have seen this in a geometry class, and you can see that that is an irrational number. What would you think something goofy like square root of 1/4? Well, that would be the square root of 1 over the square root of 4. And the square root of 1 is 1, and the square root of 4 is 2. So 1/2 is in fact a ratio. It is a fraction. So 1/2 is a rational number. Just want to kind of recap and think about, do you know how to simplify real simple ones? So here's a couple simple ones. Oop, take that back. Some simple ones that you could probably work on would be like the square root of 100. What is that? That is 10. Do you know what the square root of 9 over 16 is? Well, the square root of 9 is a perfect square, so that's 3, and the square root of 16 is 4, so that's 3/4. So you just got to make sure you know all your perfect square roots, and here is a nice little chart that is your perfect square roots. The square root of 4, and technically what I probably should do is this, kind of write this. The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16, and the square root of 25. All the way down. You should definitely memorize this chart all the way up to at least 15. If you don't, that's okay. It just comes in handy. There's a few other ones along the way that you can use too, but it makes sense to just kind of have your perfect square roots. So I hope this helps, and again, this is a very short lesson, but you should be pretty familiar with the square roots. Where we're going to go with this is we're eventually going to be solving quadratics by square rooting. So for example, if you had something like, I don't know, x squared equals 49, how would you solve that problem? Well, you would take the square root of both sides, and you would see that you would have to take the plus and minus square root, so you have x equals plus and minus 7. If you don't quite understand it right now, that's okay. That's another day. We're going to get into it quite extensively here in a few days. So I hope this video helps. I look forward to seeing you in class tomorrow, and may the force be with you.